Okay, so for those of you who need a little help trying to understand how to do this measuring biodiversity lab, especially when it comes to calculating the Shannon-Weiner index values, I'm here to help you. So let's go ahead and give this a try. So you probably, I don't know how many people you had in your transect. I used 5. Okay, so that'll work. Okay, so I had 5 people. I had them each take samples, and I don't really care about the current sample because that's just like in this case, that's just person 5. Okay, the person 5 sampled this, but I'm really interested in what was collected all along this whole transect. So I'm going to look at the cumulative value over here. So what I'm going to do is I'm just going to take this information right here, and I'm going to take a screenshot of it, click, and then I'm going to go over to here to analyze it. So here's the screenshot of that. So what matters is this. I have different species, 1, 2, 3, 4, 5, 6, up to species number 25. Now my richness is 8. That's because 1, 2, 3, 4, 5, 6, 7. Where's my 8th one? 8, okay. Yeah, 5, 6, 7, 8. I have 8 species present. If I add up all these numbers, I'll get this abundance. There's a total of 85 organisms that were in my total sample size. Now, depending on your group, you probably got more than that. Anyway, so here's how I'm going to do my calculations. So in order to calculate the Shannon-Weiner index, I need to use this equation here where this H value is the index value. That the bigger this number is, the more biodiversity a given ecosystem has. This is the sigma is basically just means to take the sum of. So I apologize, those of you who haven't had that in math class. I'm used to teaching physics where we use this with like some of the forces all the time. But if you're not used to it, it just means add them all up. Okay, nothing mathematically complex. It's just a weird symbol if you're not used to it. Okay, so here's what we do then. PI, that means proportion of an individual. So what proportion? So I'm going to take this species 1 and I'm going to calculate this right here for this species. So what I'm going to say is, well, there's 13 members of this species that were present out of 85. So 13 out of 85 gives me a PI value, a percentage of this particular one. So we could think it was P1 would be 0.0153. That's what I get that's the percentage, okay? Now, once I have that, then I multiply it by the natural log of that same value. So I'm going to take the natural log of 0.153, and that gives me this value here, negative 1.87. So this is 0.153, and this ln of pi is this here. Then I'm just going to multiply them together. So it's just this times this. So that's this times this, and that gives me negative 0.287. So that is the diversity index for this one individual species. So then I'm going to do the same thing for species number 2, species number 3. And I had to do it for all 8 of them. I'm just going to do the first 3 of them to show you. So now I go to species 2. There was 12 of them. So 12 out of 85. The percentage was 0.141. So 0.141 times the natural log of 0.141 gives me this value here. And then I'm going to do the same thing again for the next species. Now, there wasn't any species 3, so I ignore that one. I go into this one here. There was 9. So I would say 9 out of 85 is a percentage of 0.106 or 10.6%. And the natural log of that is this here. So when I multiply this value times the natural log of this value, I get this value here. So right now I've done this operation, proportion times the natural log of the proportion, for 3 different of my species. And let's just say that's all I had was those 3. Now what I'm going to do is I'm going to sum them up and then take the negative of it. So I'm just going to sum these 3. So I'm going to say 0.287 plus negative 0.276 plus negative 0.238, and that equals negative 0.801. And now I'm just going to take the negative of that, so that a bigger number means more biodiversity, and that's how I derive at my number. So I'm just asking you to do that for these 2 different ecosystems. I'm asking you to do that for the dark green one and for the light green one, to see if we can mathematically determine which one of these is more biodiverse. It's a cool technique. It's a little bit tedious. That's why I'm only asking you to do it twice. Once for the green one, once for the light green one, and then we're done. Okay? Thanks for watching. Hope this helped.